Then tell me, my dear students, you would have seen transmission lines between two electrical poles.
Yes, ma'am.
And they will be very thick in area. There will be very thicker wires. In fact, the electrical wires we use at our homes is nothing when compared to the transmission lines you see between the electric poles. And they are not insulated.
Yes,
But
ma'am. I
then
can see one of these right outside of my balcony.
they are not insulated. And you can see very large amount of current will be flowing through them. Then how is that we are lucky that we are not getting any electric shock?
Ma'am, maybe
because it is a little bit height, like on a something like a stick, it is the wire is going, right?
but birds also sit on it, then why don't they get the current?
See,
Ma'am, I think because when it like interacts with the poles, something with the poles, like there are just wires between the poles. I think there is some connection with the pole.
there will be connection with the poles, my dear, but why is that we are not getting an electric shock? Because of those thick electrical wires. One thing as simple as that, we don't anyway get in touch with those transmission lines directly.
But ma'am,
Yes.
birds do get in touch with those wires. Why don't they get the shock?
I'll come to that point also, dear. The first thing is we are not getting in contact with the transmission line. And the second point, what do we have between us? I mean, between transmission line and you? What medium you have? Is that water? Or is that air? Or is that any other medium you have in between you and the transmission line? It is the air. And air, luckily, by God's grace, is a very bad conductor of electricity. And we are safe. Imagine if air is a good conductor of electricity and charges can easily flow through air, then charges will be flowing from transmission lines to us directly. And we'll get an electric shock, as easy as that. So air being a bad conductor of electricity, even though transmission lines are not insulated, we never experience a electrical shock until we get into direct contact with the transmission line. One point. And now somebody tell me, then why is that birds are not getting electrical shock? Yeshika, please tell me, dear.
Ma'am, we already have. Ma'am, I don't think birds are conductors.
I don't think. What you don't?
I'm not sure, but are birds conductors of electricity?
You know what? When I don't know about this physics, I used to just believe that birds might be gifted by God so that they won't get electric shock even when they stand on transmission lines. Because that is the kind of misconception given by my grandmother. She used to say that because they are very innocent, birds are very innocent, and they are, you know, dumb, they can't talk. Generally, you know, somebody who can't talk will be considered very innocent. Particularly when it comes to birds and animals, we consider them to be very much innocent, right? So my grandma used to say me that birds are very innocent, and that is why God has gifted them with this power of not getting an electrical shock. And then when I have discussed the same kind of thing with my friends, then they gave me a different theory saying that birds have a special material. Their foot is made up of a special material, which is an insulator, and that's the reason they don't get a shock. And then when I read physics, then I understood those are just misconceptions. The reason is when it is standing on a single wire, it will not have any potential difference. I already told you the main reason for current is potential difference. You remember when bird is standing on the same wire with its two legs on the same wire, it is not going to have any potential difference between those two legs, and hence no current passes. But instead, if it stands on two separate transmission lines, with its two legs, one on each transmission line, then surely it is going to get an electrical shock, because both the lines will have a potential difference between them. So when bird stands on the electrical transmission lines in such a way, then they get an electrical shock. It is because they're standing on the same electrical line or same transmission line, they don't get an electrical shock. Tell me what?
So, ma'am, if like if by chance we get to like on top of it and we put our feet, just both our feet on one wire, we won't get shock as well.
Ma'am,
Hmm.
so sometimes when we get an electric shock, maybe we're touching the wire with only one hand, right?
Exactly,
But
exactly.
then how will we get the Okay, so because of touching it with only one hand, is that why we get the electric shock?
You would have seen a pole man doing some rectifications or checking the electrical. He'll be climbing the electrical pole. We call him pole man. He'll be climbing the electrical pole and will be setting up the wires and all. So by accidental, if he gets in touch with a single with only a hand is touching a wire, then surely he'll get electrical shock. If he's actually holding both, he may not, but it can lead to some other. It is very hard for him to live. Not only electrical shock, but the transmission lines will be very hard to hold on to. I'll tell you why. So you would have understood what is this electrical shock and what is the reason for this electrical shock. Okay. And then the next thing is, have you ever heard suddenly, I mean, it's not like suddenly the power goes off only in your house and rest of the flats are having power supply. Only you don't have power supply. And your father or mother might be saying, fuse would have blown off. Let me reset the fuse and you get the
Ma'am,
power.
actually, we don't
Yes,
tell
ma'am,
like
many
that.
times.
We tell like there is some in our house and like that switch goes off when there is high voltage coming and we just like on it.
Yes, ma'am, it has happened many times. So, like there is there is some sort of switches and stuff. My father goes to that area where all the switches are there, and suddenly when he changes a few things, the light comes back.
Exactly. That is what I'm trying to say. When I was a child, we used to have fuses at our homes. Fuse is a device which is made up of a thin wire made up of alloy. It is an electrical device consisting of a thin wire, and this wire is made up of an alloy, not any particular single element. I mean, we have several elements in the periodic table, right? In chemistry, we find n number of elements, but we don't use any single particular element to make this fuse, to make this electrical device. Instead, we use an alloy and we use electrical fuse. And what does this thin wire can do? You would be surprised if I say that this electrical fuse is actually saving us many times from fire accidents due to high voltage and short circuits also. Got it? It is just a device which will be a size of a battery, just a battery we use in torchlights and all, sometimes smaller than that. And that little one is able to save us, is able to protect us. And what is it made up of? What I'm talking about an electric fuse. An electric fuse is nothing but a thin wire made of alloy. What is an alloy?
Ma'am, alloy is a
Ma'am,
combination
alloy
of
is like
two
a
things.
mixture of
Example like
two or
brass.
more elements in a specific ratio.
Example brass.
Yeah, brass.
Right? So fuse is made up with an alloy because alloy is found to have more advantage over any individual metal. So this is made up of an alloy. and it will have the properties of a fuse, what it should have to become an alloy. To become a fuse. What property should an alloy have so that it can be used as a fuse? The first thing, it should have a low melting point. I tell you, and the second thing,
if it does have a low melting point and electricity causes heat, then it will melt.
This is how a fuse will be looking like. This curved line is the wire inside, is the thin wire. And this is a low melting point. What is meant by this low melting point, Nana? This wire will melt at a very low temperature. It will melt off at a very low temperature. So what happened? So when current passes through this fuse, through this fuse, see, let me tell you, we are allowed to have only 5 to 20 amperes of current to allow into our household appliances. Only this much amount of current is allowed into houses. But what if current exceeds more than that? Because somebody said high voltage. When there is a high voltage, this what happens, they said. So high voltage leads to high current. So when I have a current more than 20 amperes, then what happens? If you are stuffed with more food than you want, what will happen? That leads to negative consequences, right? If I'm feeding you with food which is more than your requirement, there will be negative consequences. So does with the appliance also. See, if I just need 15 amperes of current to run my washing machine, but I'm getting 25 amperes of current, my washing machine will be damaged.
Ma'am,
that happens with any.
Ma'am, you wrote 20
What
A.
is?
What is A?
That is the magnitude of current, Nana. Just like how we'll be putting our weight in kg, current will be put in amperes.
Amperes, ma'am. Okay, thank you.
20 amperes is the maximum current that can be allowed into houses. But for some reasons, it can be high voltage. Sometimes you suddenly get a huge current flowing into the electrical appliances. So sometimes it will be just damaging the electrical appliance, and sometimes it might be creating fire accidents also, because if more amount of current flows into an electrical appliance, the appliance will get heated up and may lead to fire accident also. So how is this fuse protecting us from this fire accident? See, when more amount of current flows through it, even this wire will also get heated up, and it is having very low melting point, and because of that, as soon as it gets heated up, it will
Ma'am,
melt.
I get it. Why? I get it now. Oh, so ma'am, can I explain what I think it will be?
No, just give me a minute, please. Let me first finish it.
Okay, ma'am.
So when more current flows into the fuse melts, and then this is it stops. It breaks the connection, or it makes. It will not allow this current to flow into the appliance. When fuse melts, it means the circuit is now open, because the other end of the fuse is connected to the house. So when the wire melts and cuts off, then it means that the current cannot flow further into the house. And that is how electrical appliances can be saved. So you have to choose this fuse with these properties. It should have low resistivity because it should allow current to flow through it, and it should have low melting point because it has to melt at a very low temperature. Only then it becomes it will melt away and will be breaking the circuit, and the current cannot flow. That huge current cannot flow into the electrical appliances, and all the appliances are saved. So Neha or Pragya, somebody is trying to say something. You.
Ma'am, I didn't get what is low melting point. And
Neha,
also,
can I explain it to you?
yeah, sure.
Neha, what ma'am told was that thin wire, which we call as fuse, it is, first of all, it's very thin, and second of all, it has a low like melting point. And ma'am has also told that the maximum amount of electric current that can be allowed into our household is 20 ampere, and if it exceeds to that, there can be many accidents, like fire can be caused, and like the machine, it can get damaged, or any other thing that uses this electricity can get damaged. So whenever like there is a more current flow in more current flow into our household, this fuse, it has a low melting point, so it melts off and does not allow that current into our household.
Okay, I understood, Pragya. Thank you.
Welcome. Ma'am, you are muted.
Sorry. I think Pragya is asking. Is that Pragya who asked? What is meant by low melting point?
Ma'am, I did not ask anything. I was just, Neha asked that like what she did not understand the fuse, so you were gone. So I explained.
No, I didn't go anywhere, Pragya, but anyway, thanks for explaining it to Neha. But Neha's question is, what is this low melting point, right? Is that yes or no, Neha? Did you understand what
Yes,
is meant?
ma'am.
You understood?
Fine. I understood everything Pragya said.
Okay. So low melting point is where every material will have a melting point. I mean, the temperature at which it melts is called melting point. Copper will be melting at certain temperature, silver will be melting at certain temperature, gold will be melting at certain temperature, and these temperatures are called as melting points. So we have to choose a fuse, I mean in such a way that it has low melting point. So at a very little temperature it should melt away, and only if it melts away it cuts the connection between the current flowing into the house, and then I mean the power supply and the current flowing into the house, and that's how electrical appliances are saved. Okay. And by the way, I told you that while explaining this electrical fuse, I told you there are chances that this high voltage, or when more amount of current flows into appliances, they may cause fire accidents. And fire is something related to heat. When objects gets heated up beyond their capacity, then they catch fire. So electrical appliances are made up of different substances or materials, and each material is having its own limit of tolerating heat. And if heat produced in them increases beyond this limit or beyond their capacity, they will catch fire. If heat increases beyond a limit, then appliances catch fire. So you can understand that when current passes through any material, it can be a good conductor, it can be a bad conductor, every material will get heated up when current passes through them. A very general example is you would be charging, you might be charging your iPads or the laptops or phones, and after a while, when you touch them, you feel them hot, isn't it? They may not be burning red hot, but they
Yes, ma'am. Like sometimes, like when I take like the classes, like I'm taking it now my laptop is on charging. Sometimes like a few times, 2 or 3 times, I felt like it was like very hot. And once I was taking a class on my iPad, and my iPad was like so hot that it shut down.
Exactly. When current passes through materials, the materials will get heated up, and this is called heating effect of electric current. Heating effect of current. This is the effect seen because of the current flowing in the materials. And materials get heated up according to their nature, according to their capacity. I don't say all of them will get heated up to the same extent. It depends on the quality of the material also, right? And there are surely certain appliances which only work on this phenomenon. When we pass current through them, they get heated up, and we will be using this heat to toast our bread, to heat water, to press our clothes. Yes or not? What does a toaster do? When I connect it to an electrical plug and I'll be putting my bread slices into it, the toaster will be toasting them, produces heat, and then toast them, right? And when an immersion heater is put in water, and I supply electrical energy to that immersion heater, after a while I can see that water is getting heated up, which means these appliances like a toaster, electric iron, and immersion heater are working on the principle of heating effect of electric current, and they are made up of materials which have high resistivity and high melting point. Like if I'm talking about a immersion heater, you would have seen a immersion heater, I suppose,